Welcome back, everyone. If you were sitting with us earlier, we had a bad start, so we're starting over. Um, actually brought up an old project that's going to help a lot. Um, Wait, what are we talking about? Talking about input buffers. What's that? Well, if you've ever played basically any type of action game, it helps make the game feel awesome. You know, we're jumping. We can't jump in the air, but when we land, we can jump again, right? If there wasn't an input buffer, I would have to wait until I landed, or whenever that flag was set where I can jump again. In this case, it's when I'm, touching the ground again. So if you'll listen on the mic, it's a little bit before I land. My buffer, I actually shortened it. It was 15 frames before, but I changed it to 10 while setting up for this video. So anyway, it's just, that's basically how many frames, it holds onto the buffer. So what is a buffer, right? It's like some padding, some extra, and so that's what it does. It collects our inputs and then holds on to them for a few more frames, however more that we want. I have 10 in here. Show this old project here. This will visualize it real nice. So right here, when I hit a button, you can see it traveling down and going up. So I'll go ahead and pause it. So down here, this is the first frame. Right here on this 5. 5 means neutral. These are the directional inputs. Here's where I pressed A, and this is where I released A. So I tapped it, held it for 2 frames, and released it on this 4th frame here. This X here means it gets used up by the input buffer. So that way, as it holds on, because the idea of the buffer is every frame it's gonna read through all these and find one for us. So like in the case of the jump, it's like we jump, and then we jump again, but we can't cancel right away. So it's gonna check this whole buffer for when we pressed A right here, and then jump again. In this case, throw a punch or whatever. This gets used up. So if we checked at every frame, as soon as this canceled, the animation stopped. If it was still in the buffer as it travels up, the animation ends, let's say, then it would check this again. And we don't want that. So when we use it to actually cancel into something, we use it up. We may still want this data here, so we have extra flags there so it doesn't get checked again. Go through there. I'll show again. I'll double tap quickly and attack. Did it go through? Oh, I hit the wrong button. So here, I've double tapped the attack. She threw her hook. That happened down here. We've gone through this many frames. We have this other press here. It's in the buffer, it's on screen here, but nothing's happened yet. I'm not pressing anything. We're going to step through. Wait for it. This is going to happen like right at the end. Boom. So it's like right before. We had about like one more frame. That was a pretty long time there. So that may not be something you want. Maybe that's too big of a buffer. And, as your game gets more advanced, you'll want longer times for certain inputs. So your buffer might be pretty huge, but you only check for like quarter circle forward inputs or double quarter circle forward inputs. You give a little more leeway. Like in Guilty Gear, 4466, those are back dashes and forward dashes, especially on wake up. You only have a few frames to like input those during certain times. That sometimes the input buffer is like smaller on wake up, so you have to be more precise. Anyway, that's more game design rather than like implementation. So anyway, here, it took all that time for it to go through, waited for the animation to end or whatever conditions you have for when you can cancel again, change your state. Happened here automatically because that double tap, even though that happened like 1, 2, 3, 4, 5, 6, 7, 20, 15 at least frames earlier, it happened again. So it gives us a buffer. That way, you know, we're doing combos, I can just do like ABA or whatever. I don't have to do it with like super strict timing. Strict timing can be good, but so strict that everything's like just frame timing, or you'll like drop combos or miss jumps. That's not fun. So anyway, step through, cancels again, she starts her hook. Let me go through there. So again, if you're watching earlier, I was floundering a bunch, so I'm glad that I remembered that I had that. So let's actually look at the implementation. In some frameworks, like my first game, Aces Wild, well, that wasn't my first, but the first one I released commercially, used the XNA framework. It held all of the like built-in input stuff in like these structs that you could, it's like, I don't know, I can't think of the word, hold in variables. Hold is the right word. In Unity you can't, as far as I know. So how you get your inputs generally, like void get my input, you do input dot get axis. I do raw because I don't like all their built-in stuff. I mean, you can change it, but it's like, what are you doing? I want it this way. And then you do like, you know, in my case, it's weapon 1. And so what does that do? It returns a float, right? So it just checks on this frame. You know, the state of this axis. And even though it's an axis, it's actually a button. That's another weird thing with Unity. If you want buttons, you could do get button raw, and it'll return it as a bool instead. I just like to get axis raw, so it's a little more raw data. It's going to depend on what you want. So the thing I'm getting at is that in other things that I'm used to, you could just do input my input, and that would be like the whole struct, right? As far as I know, I don't know how you can hold that. So why would we want that? Well, if we want an array, right? So that would be like 16 input or 16 frames of all the possible inputs. It would be pretty huge and maybe too much for what you might need, but it's fast and easy. So unfortunately, again, as far as I know, we're going to have to do a little bit extra setup, but that's okay. It's not too bad. So how I do it, I have, let me see where to start. It's kind of weird. It's kind of like all these we can kind of start anywhere, I guess. So here is that same concept, right, that I just did. It's under this void called resolve command. I do input.getButton. And it's just this input buffer item. You know, it's my own class that has just its own string called button. You know, that's the button it's looking for. I set it up here where I have a, you know, static, just a big global universal array of what my general inputs are. So I have weapon 1, weapon 2, check, dash, dodge, jump, you know, start, select, all these things. And then when it's initializing, it looks all those up, creates like a basic frame, which is all of those inputs. Let me see here. I'm getting a little too abstract. So this input buffer item is basically just that button, right? And then it has an actual buffer in there, which is the size of whatever size you want. So I wish I had a way to visualize this better. Let's go in here. So we throw that, right? I don't know if this is the best way to look at it. Shoot. Sorry again, I don't want to get stuck up here. All right, let's start at the beginning, right? So in Unity, if you're not familiar, you go to Edit, Project Settings, Input. And so this is your input manager. These names right here are a string that you set You set it right here. Again, mine's weapon, just like in here. Where did it go? So these are all the ones that I want to set up. It's collecting other data. It has a bunch of other stuff in here. But for this buffer, all I want are these. And you'll notice there's no directional input, and we'll get to that. So we check all these, and I make, it's not exactly 2D array, but it basically is. It's an array of all these, right? This is like my base array. This is just sort of the constructor. The actual item are these. It just has a buffer, a window, and then a buffer of input command items. And there's 10 of those, or however big you want your buffer to be. What's inside here, this class is just an integer and a used bool. So the integer is just a hold value. If we go here, it doesn't visualize very well, but basically I increment it up for each frame that I've held it. And so if this was visualized, it would be 1, 2, 3, 4, 5, 6, 7, and then -1. When I release it, I do a -1, just an easy way to check that. If you want negative edge in your game, which is, it'll do another press check when you release a button. Guilty Gear has stopped using that, but I think Dragon Ball FighterZ still uses it, and it actually checks for 3 frames afterward, I've heard. Again, it's going to depend on your game, if that works for you or not, if that's like too much. If you've ever played Dark Souls, and that game's weird, I mean, right, it's notoriously hard or whatever. Some of the timing on their stuff's really strict. It's like a really small window. It's okay, you panic, there's an attack coming in, and you start mashing dodge, right? Start mashing roll. Your character rolls. You dodge the attack. Great, I'm ready to counterattack. Oh no, I've rolled again. Because you were mashing, and all your dodge inputs were still in the buffer. When the dodge finished, that roll came out again, even though you only wanted the one. There's ways to get around that, where you have priorities for certain things. Again, we'll cover that in more video. Oh, maybe not again. Maybe we didn't talk about that because we had a rough start, so we're starting over. But we will do more videos with more specific implementation. We're going to focus mostly on just the buffer part here. So, just struggling a little bit on how to, explain this. Maybe just like a drawing would be better. Let's actually do a screenshot. Yeah, okay, yeah, this will be good. So this is our basic buffer, right? Inside each one of these is a buffer of, this hold and use, just real simple stuff. And maybe this part isn't necessary, I just feel like it is. And so basically what we have, is this. If we had a 2-frame buffer, it'd be like this, 3-frame, 4-frame, 5-frame, 6-frame. You get the idea. So it's a lot. It's a lot of stuff. What's happening? And so when we check for each button input. And depending on the game, like if you have core circle forward inputs, like in this I actually do, they don't show up over here, but if you'll check here, when I do a core circle forward input, held that. And this is what buffer frame it's on, 10, 9, 8, 7, 6. So it's holding on to that core circle forward for those frames. Do core circle back, drag a punch. Whoop, whoop. Sorry, I'm holding the joystick weird, so I'm jumping around. But again, that's more complex implementations. So it's holding on to all those. When we actually check to actually cancel into something, right? It's going to depend on your moveset stuff. Again, this is going to be real basic, just the buffer part. We check here, see if we can cancel or not. We update the buffer. What we do is, sorry if I'm jumping around a bit still. I'm a little, I thought this would be straightforward. We record, it's happening right here. So for each input buffer item in our input buffer, do c.resolve command that checks. So C is the input buffer item, C. Resolve command. If the button's being used, you know, we use this base input stuff. Here's a little bit of a hack, because in Unity, left on the Xbox 360 controller, left trigger and right trigger on the same axis. One's just negative, one's just positive. So I have to have a little bit of a hack in here. Not a huge deal, but it's not very elegant, kind of bugs me. Input buffer.count -1. So this is our index. It doesn't matter. Here I start at the end, right? Count -1 is the very end of the buffer. And I update it if it's being pressed. So in here, you'll see I do the same thing. I hit the button, we update down here, and as we actually update the buffer, we resolve our most recent one. Again, our recent one is at the bottom here. After we push them all up. So what happens is that we go through the whole buffer. You know, for each buffer, you know, we're doing a for loop here. Its hold is equal to the one in front of it, ahead of it, you know, higher up in index. And so maybe a better way to visualize it if we counted down and then did minus. But basically, each frame we make it the one before it, and then the last one just gets set to, you know, our new input. So then all these just check the ones ahead of it. So the next frame, you know, this guy's right here, this 5 is going to check this one. So we update the next frame, and it just turns into who it was, like the one before it, you know what I mean? It looks like they're all just moving through, but really they're all changing to the one before it until it runs out eventually. So that's like the main gist of, that's like the meat of what an input buffer is. It holds on to them for how many frames. You know, each older frame makes itself, or each newer frame makes it look like the one older before it. And in this visualization, you know, we only see that one button. But if I hit like I don't have all my inputs set. Sorry, when I brought it into this new Unity project, it reset all my values over here. But really, it's holding on to all this stuff on each one of those frames. I'm just visualizing the ones that, you know, are actually being pressed. You know, like A and B are being pressed there. So there's a lot going on. It can get a little confusing, but it's not too bad. So we step through there and we resolve this command, right? If that button's being pressed, we do hold up. If you don't know what I'm doing double click on a method and hitting F12, and it'll take you to the implementation of that, which is really handy. If hold is less than 0, this is actually a little bug I fixed just now. Because when I release hold, I set it to -1 as a way to, you know, flag that it was released. If you wanted, you could have, you know, something like that, and then you wouldn't have to do it with the -1 stuff, but I preferred this. Well, I don't even know if I prefer it, but just what I had. So if hold is greater than 0, whoops, looking at the wrong one. If hold is less than 0, hold equals 1. This is just in case if through incredible dexterity I released and pressed it again on the next frame, that I would actually get 1 and not 0. Because if we're holding the button, hold plus equals 1, right? And you'll notice we're not doing anything like get input get axis raw, or hold on, get button up or get button down, because we know that it always resets to 0, and so if it equals 1, that means we pressed it. So that means it's this frame here, the press frame. Well, that's not a good example. It's the press frame right here, right? Because right here it was 0, here it equals 1. I have a little visual indicator of the V, you know, like pressing down. And then A, this is the frame I was no longer holding it, so it's set to -1. So if a button's being pressed, then we do hold up. Otherwise, if it's not being pressed, it's real strict, like nothing else going on, then we for sure do release hold. If it's greater than 0, if it was being pressed, then we set it to -1. We also do used equals false, means we can use it again. Then hold equals 0. So we're updating our input buffer. And then we actually update our move list. Again, I'm not going to get into too much of like how to implement this in this video, but we'll get to it because you have to kind of understand state machines and things like that. So it's real complicated. Just as there's just so many more special cases that start to happen. But I'll get to the stuff that will just explain like how this is working. So I have all these like special cases, like well, there's some that are important. So we go through our move list, and I'll show you a move list real quick. So this is my move list. Again, this is going to be a little more specific implementation. Some games need very little stuff for their state machines. This game is very complex. You have these big move sets that you can customize, so it's like a really complicated thing. That's why it's a little rough on showing you how to do it, but we have our player, we have our move lists. So these are like the possible actions. They're just indexes, going to like a global action list. And here's the actual commands that are required. So here it's a simple one like press B. And so it happens, so we'll show that one. We have jump, if we can jump, if we're grounded or not. Press D. Let's do another more complicated one. Hold RB, press A is another one. So how mine works is that it goes through my move list, checks, and this is where it gets crazy because for every single move, every single input, you check the buffer. And the whole buffer is this whole huge array that we have. It seems slow, but it's pretty fast. And there's little ways that optimize it. We stop as soon as we find one. You can kind of check along the way too. But if you have like a priority system, you kind of have to check everything anyway. So if we have something like press A or quarter circle forward A or hold R and press A, we're probably going to want to like prioritize one. And so you kind of have to go through the whole buffer, see which one had the most priority, and then actually execute that one at the end. So anyway, we go through our whole move list. So move list.inputs here, or current move list.slot, that's what I call them. We check that priority or not. If it's less than, then we don't care. We won't check it. See if we can cancel. Certain moves have special cancel states, like being able to jump or not. In this game, there's some, sort of more spectacular moves where you can cancel your hit stun, like ninja style, like return into smoke and drop a log or whatever, and, do cool stuff like that. Or other just special cases where if you get parried, you can't cancel into everything, but you can cancel into other stuff. So again, it's really game specific, but just showing you how complicated it can get, but how important it is. It really helps with game feel and just having good games. Going through the move list, go through each slot. Okay, we can cancel. We're the right priority. We hit that move list, and then we go through each input. And so that is, right here, hold RB. So this is our first input. And it's a special, like, hold. This is just something I set up myself. You'll have to, again, it's a real specific implementation. I probably wouldn't even recommend this one. I really wanted like a universal sort of implementation, but it's just they change so much. Like Even though Ace is Wild and Citadel Deep were really similar, like this is a lot different than what I did in my previous one. So sorry about that. I wish it could be maybe as we go along. You know, again, this will be a multi-part video, I believe, and we'll hopefully improve that. Maybe find like a modular, you know, just big code snippet I could share that y'all could use. So we hit that move list slot. You know, we're checking, you know, this command like fireball or just basic jab or, you know, your jump, whatever it is. And then we check the inputs. For a hold input, we don't have to check the first buffer or the whole buffer. We just check the first frame in that buffer because we want to know if we're holding it right now, not if we held it in the past. Certain moves you may want that. You may want it where two buttons are being pressed at the same time, which is a little bit different than like hold target and hit a button. You know what I mean? You may want something where you hit A and B at the same time, which is a whole other can of worms because you have to do carry canceling or everything has to be just frame. It's nonsense. But in this case, I just want to make sure we're holding it right now. Or on that frame, rather. I guess it is on that frame. No, because it's always like the current one. Interesting. I'd have to do some testing. It works, so don't think about it too much. But basically, we just check if hold is greater than 0 on the current frame. You know, input buffer.count -1, which is this one right here, our very first one. So if we're holding R or whatever, then that checks out. And so we'll move on to the next input. If it fails, then we break out and we stop checking this input. That command was not met, so we just bounce and go to the next one. If it is, we go true, and then we go to the next input command, which is, you know, not input presses that we've done, but what that move requires to be executed. You know, in this case, hold RB, whoops. And press a button. And press B, whatever. So then we check again in the buffer. Now we'll actually hit the buffer. So for these certain special ones, you don't necessarily have to check the input buffer. Just check if we're jumping, check if we're holding a button. Here, we actually hit that buffer. So for each input buffer, we do, you know, that buffer item B can execute. So we go to it. It's pretty simple. If hold equals 1, that means we actually pressed it, that we hadn't been holding it. You know, if it's greater than 1, then we've been holding it. You may want that if you want like a game where you hold down a button, you keep shooting, things like that. Or if it's 0, it means we haven't pressed it. Or if it's -1. If you want a negative edge, you would do this. Let's see if it works. I'm curious. Should. I haven't tested this. I'm curious. So I tap A or whatever. Oh, it's not working at all now. What happened? Oh, whoops. Or I love this song. It's so sweet. Again, I can't remember because we had that bad start. Listen to Street Fighter 3 New Gen Original Arrange album. Well, you know, one of my favorite characters, her stage remix. It's so sick. All right, press it. I'm pressing it, now I'm holding it. You can see I have like a hold command where like it gets really weird. So anyway, I'm gonna release it, and she swings. Some people have that like instead of -1. Well, no, they still have that, but they just don't have it on their basic commands. They have it on like just fireball commands and things like that. Anyway, just something to think about. Oops. So can execute, hold equals, and hasn't been used. So as we go through, you know, this checks out. I have some weird, I hold on to those variables instead of just doing like strict if statements because I need to check them again down here for reasons. Input complete equals true. That just means like, it's like a real command. It means like, I actually pressed a button. I don't check this for like holds and special conditions. It makes sense. Like, it's just really hard to explain it. I hold on to the button, meaning it just like gives me a really universal way to have like chargeable or holdable attacks, so I can just hold on to this like global variable. Latest button, same thing. Here's a little interaction check, so it's like different from our normal move list. If I want to open a door or something, it's set to my jump button. So I'll mash and jump here. If I go up to this gate and press jump, I don't actually jump. The gate opens, and then these guys punch the shit out of me. Same thing with these doors. Oh no, it didn't work. Those doors open. What happens is it eats my input, which I want it to do. Used equals true. So again, one of the conditions for this being able to execute is that hold hasn't been used yet. So we set it to true, so it can't work. And then I set some context stuff, and I break out of the loop, so I stop checking. And context stuff is to actually do like in-game interactions rather than like my move list interactions. If I go through all that and it still doesn't pass, then I just break out of the whole thing. But if we pass all those things, then we hold on to that slot in our move list, and we check that slot and check its priority, and we set that. And then we go on to the next one. So that way, when we come back up here, we check to see if that priority is less than or equal. Is that a mistake? Oh no, less than the next one coming up. Right? Anyway, it's set the right way. It's just a little bit confusing way to do it. So we passed all the tests. We got the one with the minus priority. Then we go through and we do current button.used. Again, that's just so we don't check it again. I have some special cases for, I'm starting a new thing. This advanced step thing is real specific to this game, so you wouldn't necessarily want to do that. And then current action equals current move list, set to that action in that move list slot. Hold RB and press B is, I have to check my move list. Oops. Press B, burst draw. This move looking pretty sick. Boom. So, I just feel like we've come to a sudden stop. I don't know. We'll do a review here. Hopefully, get everything straight. It's kind of complicated and it's kind of weird. And again, this implementation here will be specified in a later video. Need a drink 1 sec. So from the top, first thing you need to do is set your inputs. You're inside of Unity, project settings, input. These names here are strings that you specify yourself. There's preset ones. I'll probably actually redo some of these because the nature of the game has changed. It checks another string here that's based on like some joystick stuff. Again, this is outside of the scope of this video, but this is just sort of how you start. Set up all these. Maybe it's just attack and jump. And so whatever buttons you want to check that you want in a buffer, you set up this basic frame here, which is a list or array. It doesn't matter, I'm just saying. You can actually use either one of all those items. So this is just sort of our base like interface for checking against Unity's built-in one. Because our actual input buffers are over here. So we have an input buffer item, which is a string, which it gets from this. And so when we construct that, we go through here and we make one for each one of these. We make an input buffer item, or excuse me, an input command item. No, sorry, the names confuse me. An input buffer item for each one of those. So right here, we have our input buffer for each one of those. In here, we make a new one. So we're making 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. We set it to this name. You know, we make it, assign it to that button. So we add, it's built into the constructor. Oops, I don't know what I hit there. Gosh darn it. And so when we make a new one of those, we take that string, which it pulls from here, set its button variable string to this, you know, whatever. When we go through each one, first one's called weapon, first one's weapon 2. We make a new buffer, which is actually all that hold and release nonsense. And that's the actual buffer. So we make, in each one of these, we make as many as we specify of these on another array or list. You know, we do 10 in this case, and that's your input buffer size. So let's set it to 60, just so you can see. You have an idea of how it can be bad. We showed that in the beginning of the video, but I'm just going to hold on to our inputs for a whole second, which is kind of crazy. So I'm like, so if you can listen, so hold on to that second one for like ever. And you can get really lost. Like I hit stop pressing stuff for a long time and then keeps it going. So you're gonna go a little bit higher. 15 was what I was working with for a long time. 10 seemed a little small for some stuff. Actually, I'm gonna do 13. So that's the buffer, right? We have that set up. We go through there, just make a bunch of these. You know, each one of those is basically an array of itself. I mean, it's not necessarily itself. You could do that if you wanted. I just find it easier to set it up with like an extra class in here, or just have a hold and used. You could have all this in one class if you wanted. Just have all this inside of this same class here. It would just be a little bit redundant with this part, so it's up to you. You have to update your input. So this happens every frame. We update the input buffer. Forgot to talk about this, update left stick. I don't need a buffer for this stuff. I don't do any directional input stuff for like special commands. It's just for moving around. So I only need to know what the current state of the stick is. I still hold it into my own little variables here. So left stick X, left stick Y, input.get access raw. Actually, in a previous video where we did third-person camera controls for 3D games, we cover this. So nice little throwback there. Update left stick, and then we actually update the input buffer. So we go through each input buffer item. So that's not the actual buffer yet. That's each one of these. So we go through this one, check its whole buffer, you know, all 10 or 12. I think we set it to 13 now. And I'll go through all 13 of these, all 13 of these, all 13 of these, all 13 of these, and so on. Resolve command, you know, just checks if we're pressing it or not. This first step, we're actually not going through all of it yet. I got a little ahead of myself. The first step, we just check this command here. And again, we check the one at the end, and then we move them up. You can go any direction you want. It's just important that you're checking from the right end, you know, in order. You want to check the oldest one, basically, first. Now again, in this visualization, we roll it up like this, but we check. Well, I want to make sure. Yeah, that's right. Sorry, someone's knocking. Hello? Told them I was recording, but that's all right. So we go through the input buffer. The last input buffer item is set to our current state. So we check that button. That button was set in the beginning. We do input.get button. This is very specific to Unity, how this implementation here. Again, there's a little bit of a hack to get around that stuff here. Do hold up if it's being pressed. We increment it up 1. If it's at -1 or 0, we just set it to 1, and then any higher we go up. Again, 1 is an actual press because the previous frame was 0. Then we go through that whole buffer again, like I said. 13 of these, 13 of these, well, 12, -1. And for each one, you do the hold and the used equal to the one before it, right here. So this one's going to turn into a press, then this one's going to turn into a press the next frame, and these ones are going to give it up as we go through. So that's the buffer. It's updating fine, and then you have to set that against your actual, it might update input. You do update the input buffer. Then we actually update the move list. You can see here, this actually returns a bool, that whole big mess. And if that happens, then that new action actually do a start action thing, which is a whole thing that you'd have to implement yourself. Gosh, I love this song. It's my favorite song on the album. We go through, most important thing here, for each input buffer item in there, B can execute, if it's 1. So the basic implementation wouldn't be all this mess of stuff. You just go through each input buffer item after updating it. If it can execute, that means hold equals 1, which means we press it and it hasn't been used yet. And if that executes okay, you might have to do some other checks to make sure you're actually executing into the next action. We do current button.used. This is just a way for me to check, again, because I go through the whole input buffer for like the whole move list. So I have to hold on to that button, current button. And then if that actually executes, then we'll set it to used, so that way we don't check it again. And then we'll actually execute. I believe that'll do it. Again, I may not have like some good code up right away. There's not much to it. You could basically get it from here. The simple concept, the base concept is fairly simple. The main thing is just knowing to check the right direction. Again, we update the last one and then move them up, and then we check from top to bottom. So it can seem a little slow because we're doing all these like extra checks, but it's important for the buffer to work. So again, we swing, or we press the button. Why is player 2 moving now? Whatever. Oh, maybe I jumped over. We hit the button. Starts at the bottom and moves up. And we check from the top. That part's a little bit weird, so it's just important to remember that. If you like check from the bottom, then it's not going to be working quite right. But yeah, that about does it. Again, we will do some more specific implementations on like actual state machines and things like that, bring that all together. Just understanding an input buffer is important. If you just wanted like a real simple one, again, you probably have code like this in your game already. If input.get button, do attack or do jump. So instead, set that to a buffer, update it as such. Set it to the last spot, update all previous ones to the frame before it. So they, whoops, I do that all the time. Oh, it's not loaded anymore. So as they move up, and then remember, check from top to bottom, check it's oldest to newest, even though it's like they're on top. It's weird. Instead of just doing this right here, just do that extra step. And then again, that one of the big things is to have that used bool here. When you let go, used equals false. And when you press it, it doesn't equal used. But if we actually execute cancel into a new command, then we use it up. So that way it doesn't get used again. Yeah. If you have any questions, let me know. I'll have a little bit of code there. Mainly this one here. Probably have it like in one class. Hopefully it'll be a little bit easier. And try to make it a little bit more universal for Unity and just anything that you might want it for. You're not going to want it for everything. Even an action game with lots of moves and weird cancels and stuff, you don't necessarily want the buffer for everything. In my case, I do. A lot of my influence comes from fighting games, so it's kind of like this strict state. I don't know. It's hard to explain. Yeah, that does it. Sorry, I'm kind of jumping back and forth. Thank y'all for the support lately. I know it may start to sound redundant or like a platitude or something, but it's not. I really mean it. Feedback has been really fun. Please let me know if there's any topics you'd like covered. I was really hoping to get to some animation stuff, but I've been working on assets too much. I really got to do level design. And I want to double dip a bit, so I want to have a new character, a new enemy setup, and then we'll do some more like animation. I have some old animation videos, but I want it more in this like structure where I'm a little bit better, focusing on getting information to people so they're like more compact and more about the knowledge than just like going through it or whatever. But yeah, thank you all for the support. Please let me know if you have any questions. This video will be available at patreon.com/cultureattack, which is my Patreon. It's where all our videos are. Again, all relevant assets will be made available as well as they're free. Big value of Culture Attack Studio is free and open information, techniques, and knowledge. Information and knowledge, is that redundant? Anyway. Our assets are also available, but those are for educational use only. So please don't let any of that stuff show up in your game. But I do want it there for y'all to see if you want to look. I know when I was getting into 3D, I asked a lot of people if I could just see their 3D models, and they were really wary about it. I mean, I can understand it, but I had no intention of just like using your stuff. Because if I really wanted your stuff, I could just, there's ways to get it anyway. Anyway, I got a little negative there at the end. Want to keep it positive. Thank y'all so much. This video's been fun. It's they add a lot to action games. They're really important. They don't have to be that complex. Again, you could just have like a simple input here that you check with a used or not, and so basically it would just be a string and then a used value. Just have a big old array of that for however many commands you want. Mine's just a little more structured because there's so many commands and possibilities and stuff. So yeah, that was a long goodbye, but I'm really thankful for y'all. This is getting funner and funner. please let me know. I don't always know what people want covered. The previous video, like last week's video, I would like to do a step-by-step. I kind of wanted an overview, but then like after I sat with it, it felt a little weird that I just sort of glossed over a bunch of like different effects. So we'll maybe do step-by-step. I don't know. It seems like I covered everything. I don't know. But we'll catch y'all later. Thanks so much.